Thank you, Wes, and good morning, good afternoon, everyone, wherever you are. It's great to be with you again. I thought I'd send greetings from Oslo, and the reason I wanted to say that specifically is I'm very excited. This is the second time in 3 weeks I've actually done international travel. Had to show all my little bits and bobs to actually gain entry, but it's very excited to be on the move again and going back to the UK later this evening after I've done this presentation. So. Anyway, great to be with you, and thank you for coming to join. That's great. Right, so you've heard the topic, and I'm sure you're thinking, oh no, Rayner's not talking about time and timing again, because I think I've done a couple of previous presentations in the last couple of years about this. Very specifically, I wanted to share this this fall because I've got some very specific elements I want to talk about, and I'd like to actually do a bit of a call to arms as well to people to get involved. So in terms of what I'm going to be tackling today, I'm going to be talking about the current situation that we have in terms of the way we time in IP production, what the ideal need is, where we would like to get to, what we think the solution is, and then the call to arms really and how we're going to actually create some engineering guidelines or recommended practices that actually address that. So that's the next few minutes we're going to be talking about. So you have probably seen this slide of mine a few times because this is one of 2 or 3 stock slides I try and use to frame the context of where I think we're heading as an industry. And when I say end game there, I don't mean like the end of time. I mean this is like the where we're aiming to get to as or we'll end up as a final solution. Specifically, those blue arrows into the orange bars are the points where we actually will always end up with or always have a real-time flow with effectively aligned media essences, video and audio. So at the acquisition point, obviously, the vision, the audio, the metadata that's being captured live are all inherently aligned at the moment of capture. At the point on the right, in terms of the final consumption, at the point it presents to the person on their mobile device or their television or whatever, then it's, those essences need to be playing in real time and live. And then similarly in the production environment, the people in the gallery, the people in the sound booth, all of those, they need to have those the media essences both as linear flows and time aligned. But very specifically, the time domain that the production people in fact, the audio and the video differently, maybe compared with the end consumer, are obviously different timing planes. But I'll explain what I mean by timing planes as we move forward here. This picture, again, it's one of my generic pictures, and I think it's useful to have the context of why timing planes is becoming even more of an interesting challenge as we move from just a traditional central facility, which you can see on the right-hand side of the picture there, where everything is co-located and fairly closely timed, as we're starting to use, potentially fairly wide geographic distances for different elements of production, then implicitly we're involving more time and latency, and therefore some of the challenges of the timing planes become even more significant in how we want to manage and be able to manage those. Again, this is the final, I think, of my generic slides. Again, I've shown this a few times. Basically, almost ever since the start of the journey that we've been on as an industry with ST2110, and speaking a bit to, I guess, my naivety and assumptions I made at the beginning of the journey we were on, but also where we need to get to. Oh, I think someone's unmuted. I don't know whether you can mute whoever's just come unmuted. We have on the right-hand side of the picture there what I call use time. Now, if you consider the top line to be a video essence flow of in a production going through a switcher, going through other processing, it could be an augmented realities process, whatever is in there. The bottom line, the audio going through various things, including a sound mixer, etc. At the point where you're actually needing to reconcile those essences together for either previewing production purposes or for final direct to home emission, you need to be able to pull those together. Now, traditionally, you know, we've had techniques for dialing in delay to actually allow for that, and effectively in the IP world, that's still what we do, because we don't have an ecosystem that allows us to trace accumulated time through the different essence paths. Now, in some ways, 2110 could have done this. We kind of made a few decisions on the way we defined timing and using the RTP timestamp that could have allowed for that. And indeed, some of the work that's happened recently on the revisions to ST2110 actually do allow for the provision of the propagation of timing information through devices, such that it is possible, you know, in band, if you like, within the flows, it would theoretically be possible to actually recover time at the end. But as I'll outline, the recommended practice or the guidelines we're aiming to produce on this actually work on the basis that that's actually probably not going to be possible in band, and it's going to need a control system assist to actually allow us to build a complete ecosystem. So just quickly looking at those changes, and you know, whilst it wasn't implicitly defined, it wasn't excluded in the original 2110-10 standard, the concept that a device could actually either create what we call a new timing domain on its egress flow, as on the right hand side there, or like the two elements in the middle, preserve the timing information. So if you'd like to think of this very simple diagram here as a chain with a source such as a camera on the left hand side, that time domain I call T0, what we've been calling in some of the discussions origination time. But that's the, if you like, the sampling time that's, you know, is defined in RFC 4175 and ripples through into 2110. That we then have the potential, you know, if a device, for instance, a vision switcher, maybe that has 1 or 2 frames of delay, then potentially that could egress the same frames with the same timestamp, or it may do it with effectively a timestamp that's 2 frames later because it's doing a new at the end. But if it was a preserver, it would preserve that. And if you had preserving devices through each chain, both the audio and the video and the metadata, brackets, we think that's unlikely, then you would be able to do the reconciliation I talked about just by comparing those RTP timestamps. But the reality is we're probably going to have a mixture of preservers and new. And one of the additions in 2110-10 that we've made recently is the concept of allowing devices to declare whether they are preservers or they effectively new. And if they are new, are they origination new, or are they, you know, effectively another timing plane new? My good friend Pren Boone did this diagram, which I have stolen wholesale from him. I don't think he ever intended it to be shown at conferences such as this. It was always intended as a private discussion point. But I think this does actually lay out just some of the concepts quite well for us to look at. So I think it's a worthwhile diagram to consider for a couple of minutes. So if you look on the left-hand side of the diagram, you can see we have your cameras, which are what I will call, and you'll see in my timing diagram in a minute, origination time. We've also got graphics engines and replay servers, so synthetic sources that will be acting with the creative intent that they are in real time at the moment. So most of your devices going into your vision mixer are actually have the intention of being in the moment as real time as they are then. So you've got effectively nominally aligned sources. You will also have what I call rogue feeds, outside sources that will need to be reconciled into both the house timing, frequency and phase timing, and then effectively calibrated as T0. There are some gotchas there, and we'll talk about things like radio cameras in a minute. But what I wanted you to look at there is, you know, this is assuming that it's a large event production that's syndicated. So that vision mixer, the first vision mixer we come to is the syndicated feed. We then have like the individual consumer of those doing their own unilateral program presentations. And what you can see there, very specifically from one of those two cameras on the left-hand side, is it's being consumed by the host production vision switcher, but it's also being used as an ISO feed into the downstream switcher. So immediately we've got that one source that's crossing two timing planes, because it's effectively not going to be fully synchronous to the second vision mixer if that's also taking the syndicated output from the first vision mixer, etc. You get the idea of the concept of these things that stretch across different timing planes. And then if you look across the thing, you see we've then got effectively another timing plane on the unilateral program presentation. And then if we've got like an MCR function with a switcher back at the studio, that might even be yet another different timing plane. But talking of timing planes, I thought it was worth, and this isn't intended as an exhaustive statement, nor is it sequenced, nor is it concatenated linear, but this is just an example just to help you get your mind around some of the timing planes that exist, and then we can talk a little bit about what that means. So you can probably see the second green line in from the left I call T0, and again that's what I was just calling previously origin time. And that's the concept that all of the sources, the cameras, the synthetic sources, the graphics replay, are all intended as in the moment. So they are all effectively would be tagging themselves with the PTP now time and pushing into the event production switcher and audio mixer as time now. Potentially, if you've got another downstream switcher of that would be in another timing domain. I mean, some of these probably are only one frame. Typically, I think production vision mixers are one frame in to out. Some a lot less than that, but in IP world, most of them end up being reconciled to an integer one frame. We've then got, if you look downstream to the fifth line in from the right, the green line, we've got potentially remote control surfaces. And I know a lot of people have been doing a lot of this, but the concept that, what we are doing increasingly is potentially actually having the surface where we're actually controlling the production remote from the actual location, which means the timing plane you're making decisions in on your proxy compressed mosaic that you're using when you're operating that remote switcher is actually a slightly different timing plane. That might be a handful of frames later, and I'm not going to go through all of the implications of that now, but just to point out that is a different timing domain. One potentially really large different timing plane that exists is remote international commentary. Typically, the way that is done quite often is with a compressed video proxy. So the compression takes time. It's then sent over public internet. So typically there's a fair bit of buffering there to ensure reasonable performance. And then the remote commentary is being done and sent back. So you've got that round loop. So that could be, certainly wouldn't be surprising if that's the order of a second that you're adding into your overall production time to allow for that remote commentary loop, if you like. We've then got, as one of my learned colleagues suggested, the option of a profanity delay, which is an intentional latency we would introduce into the system to allow us to recover from unwanted situations. And then, something that can take quite a few frames of processing is if we're actually running in the studio or even on location an enhanced, an augmented reality or virtual reality set, then some of those are typically up to half a second's worth of latency that they may incur. And again, you need to allow that in your system. And then at some point at the end, you've got a final timing plane where you're actually emitting. So all of these things potentially induce a new timing plane, and obviously I haven't shown them as concatenated here, but so several of these things actually have to work in concatenation to actually have to get the complete workflow together. So you could be looking at quite significantly incur delay. I think I've already talked to this one, the fact that you can have some feeds that are being used in multiple parts or multiple timing planes within the production. I also think it's worth saying I've been talking about everything I've been talking about so far. I guess you've probably had the mindset of a traditional appliance-based infrastructure, a box that is a vision mixer, a box that is a replay engine, blah, 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 all of those elements. But obviously, back to my very first slide of moving to a fully virtualized world, all of these things are effectively, in our end game, going to be virtualized processes that consume an amount of time to do those processes, but also actually maybe realistically, if their compute functions, be slightly less deterministic in the actual processing time they take. So we've got these elements there, and those non-linear times, I think, is also the other thing to talk about, which I think we've probably not got too many of left in the system now, is the challenge if we've got things that have variable latency. Older generations of vision switches typically had that. If you've got cascaded MEs or other input frame store functions and stuff, but typically those are now more of a constant process. Just to go back to why we've got to where we are, and I think I've mentioned this previously, but AES-67 very much used RTP timestamping as was originally intended in the original 3350 or whatever it was RFC for RTP. But the concept that AES-67 came up with is you nominate a presentation time, which allows for your network latency and other stuff that you need to allow for, like PDV buffering, and you create a presentation time. And we need to get our minds around. So AES-67, for a start, doesn't allow what I call that, inherently doesn't allow that propagation of time, that preserving of time. It would be wonderful if it did, and there's nothing that precludes the audio devices in the 2110 system from doing that as we move forward. But AES-67 very much had the mindset of using it as a link-based as a link-based timing, and with defining a specific point to specific point presentation time, and that can work in this hybrid system that we're talking about. I think I've already talked about this, the concept of the virtual processing functions propagating. Just very briefly, and thanks to John Mayotte, who chairs this group alongside me in VSF, and a big plug, if you're not part of this, do get plugged in, because it's a great piece of work that's going on. We've been looking within the activity group about the concept of time, how we actually handle timing in cloud infrastructure, and very much, without going into too much detail, the concept we're doing is effectively that preserve. So although we're moving into a compute time where it's a much more bursty handling of stuff, there is still the inherent need to preserve the origination time as we actually propagate through cloud infrastructure. There is then this whole discussion about the accuracy of time that's needed within the compute infrastructure. And again, that's not the job of this presentation to cover that, but we can talk about that some other time. Just very briefly, and again, I don't want to dwell on this, but the concept also, if we are actually talking about different proxy timing planes for some certain types of remote production, then there is the concept that we actually need to manage like negative time if we're trying to impose the creative intent of exact transition points as done at the control surface back on the original content. But again, that's just a comment for consideration rather than something I'm trying to talk about here. So this is where we're getting to, cutting to the chase, drawing to a close now. Hybrid timing reconciliation. So if you look at my blue arrow at the top hopefully some devices within a system will do timing chain preservation. So they will be preservers of the origination time through the system. And hopefully more and more devices will support that, so systems are able to actually understand that the timestamp they're looking at on the flow coming into them is or is not an origination time. So as I said, if that was the case end to end, then on that red vertical arrow on the right hand side, you would be able to make a decision on your own from the in-band RTP timestamps that allow you to allow it. But because we understand that that's not going to be the case for whole ecosystems, we actually are going to need to do two things. We need the devices in the chain to have certain behaviors, present certain information to the control system, and the control system will need to provide some additional functions that it doesn't do today to actually provide time coordination. So it can actually then make the aggregate timing information available. So any point in the chain that needs to reconcile the different timing flow of essences can actually do that in a coordinated way. So this is kind of my summary of what I'm saying we need to make that work. So we have every processing device in the bottom in the orange providing the necessary information and accepting the required configurations such as presentation time a la AES67, within those devices, and then the control system that's actually doing the aggregation, because any device itself is never going to be aware unless it sees an origination time flag coming in. It's not going to be aware of what's actually happening unless the control system can give it the end-to-end story. So what we're looking to start work on very, very imminently is a new engineering guidelines or recommended practice, which is really a system level architecture. What we've done with 2110 and all of the other specifications, we've really been defining interfaces. We haven't been defining systems, and we're building systems. And this is all about how we make a system work, timing work within a system in an automatic way. It has to be possible in today's age, with all of the technology we've got available, to make a system solution that allows the automatic reconciliation of media essences. And that's the intent here. So hopefully that resonates with you. Hopefully that's something that you can see the need for. So it will be really great if you can get involved. If you've got any examples of user stories that you would put in to actually help us build the requirements. If you can think of any gotchas, corner cases that are things that may challenge the kind of architecture we're proposing, that would be great. And finally, if you're up for it, throw your hand into the ring and come and get involved. So hopefully that's been of some inspiration. At my usual offer, now we're starting to travel again. I would love you to join me somewhere or other for a very nice cup of tea. And thank you for your time this morning, this afternoon, wherever you are. And it's back to you, Wes.
Well, Andy, we've got a couple minutes here, and so I thought I'd open it up for questions to the audience. Rahul, we'll get to you shortly. I had a question. Talking about all these timing planes and the remote commentator stuff that you were talking about. Has anybody given any consideration to actually trying to do something about bringing the captions for live events more closely in time with what the speakers are actually saying on screen? Have you heard of anybody thinking of doing that?
I've heard various conversations about that, and again, I guess that's part of my, if you like, bigger vision for the potential ecosystem we're talking about here, because we don't just need to, this control system or this architecture, this hybrid architecture we're talking about could do so much more than just compensating for your scaler and your video switcher and your bug inserter, whatever functions you've got in your line. It could actually, assuming you've got a technique to use it, it could actually compensate for your remote commentary loop. It could compensate for your AR system. It could compensate for all of those other things, the latencies that each of those processes incur. So, I think there is an immense potential to build a system that, whilst I guess there was a bit of a narrow focus in my original vision of the intent there within the initial, concatenated processing elements that are part of the chain, but it could actually subsume everything within the production environment, and there's no reason why what we're talking about here couldn't subsume that. The discussions I have heard so far have been ad hoc, so to solve some of those bits. So what I'm saying is, if we're going to tackle this, let's try and tackle the bigger picture and create a holistic system that actually allows us to actually accommodate all of these things in an open manner.
Great. So I see a comment here real quick. Let me read it, and I think it includes a question. Says a brilliant presentation, Andy. And that's after the other comment that said excellent presentation, Andy. So nice job. Nice to see a move away from tight synchronization with precise timing at last. One corner case is the long distance two-way interview where a single signal may need to exist in multiple timing planes at the same time, but in different places. You have any
Yep.
comments about that?
Yeah, no, I think that's a good, and those are some of the kind of cases where you've got, yeah, things that need to exist in multiple timing planes as you actually ripple through a system. And I think the architecture that I would like us to create in this EG or RP actually should accommodate that. So we actually create a system that's capable of actually handling that. So yeah, that's great.
Okay, here's a question. Thanks for the presentation, Andy. How will the control system and the media processing devices communicate? Is this supposed to be done through NMOS, for example?
Okay, so I think we're going to work that out. I mean, within the SD 21.10.10 revision, we've actually defined in a fairly non-committal way that the processing devices will need to expose information such as their processing delay, and and the timing that they see incoming to the control system. I think there were a number of ways that could happen. Because those are going to be static things, they could be in the SDP, but they could be fetchable in other ways. I've got an open mind in some of that. It could be an addition that we actually build into the NMOS toolkit as well. So at the moment I'm not trying to shoehorn in specifically where those are going to be presented. What I would like to use is an existing communication system that exists, rather than we don't want to create something else from scratch.
Yeah, and a whole new timing chain. Okay, one more question here. It says, are there any particular parameters to be aware of if you're comparing cloud providers? Maybe things like items that are standard features for one, but optional for another.
Okay, that's a very good point, and specific with regard to time. One of my big missions is I think people that have come from the world of PTP and microsecond or nanosecond timing in broadcast, there's been a mindset that we need to impose that kind of precision timing on a cloud ecosystem, which is simply not necessary. But in terms of maybe what's being talked about there in that question is the infrastructure that the cloud provides, not just with timing, but with other things. Where we're trying to pitch in the ground to cloud, ground to cloud, cloud to ground work, and other kind of industry related conversation is very much at the kind of media interface API layer upwards, rather than being consumed with any vendor specific ecosystems. So we will need to access NTP time, and we will need to access a technology that's provided by that cloud provider that gives us time-bound integral data transfer. And there are certain ways that certain vendors have already announced that allow us to do that, and others may be announcing different things, but we don't want to get bogged down with that. So I'm trying to abstract all the considerations we're doing, and that's certainly what we're doing with the GCCG work as well, above anything that's vendor specific. And not just for public cloud either. So we're not just talking about the public cloud providers, but this needs to be able to run on private compute in exactly the same manner. And hopefully everything we're going to define will be abstracted sufficiently to be able to work on that, as well as with appliances, traditional broadcast appliances, and also with a hybrid of those. So a concatenation of, some virtualized functions along with traditional broadcast appliances. That's the dream.